And by the way, in zero gravity like we had before, legs are not necessary. I'm handicapped. I can stand up for maybe 10, 15 minutes. But there's so many people that are in wheelchairs that don't have legs. Imagine being freed from not having to have that. On the moon, I could see a great retirement place. 1/6 Earth gravity. I could stand all the time, all day long there. Next. Next. So the moon is a great place also for astronomy. We've had some fantastic discoveries with the Hubble Space Telescope, but the problem with space telescope things that are in orbit is stability. We have to have these control moment gyros, which are going all the time and keeping it exactly stable. But even then, there's a little bit of wobble. And that little bit of wobble, even though we do a lot of processing with it to get that wobble out, imagine if you have a dead, steady place to put it that has no atmosphere. The moon's a perfect place for that. And if it happens to be in the geometries where that's facing towards the Earth, you have a wonderful, by the way, one side of the moon always faces the Earth, and one side of the moon always faces the darkness, and that's not true. People always, there's a dark side of the moon. So what really is happening is the moon is rotating, but we only see one side of it. Okay, but one side is facing towards the Earth, so it's a great place for observing the Earth. And the back side, click one more there. Dale, one more. The back side is perfect for radio astronomy. Radio astronomers around here are completely driven insane and mad because of all the RF radio frequency interference, because we have all these radios, whatever else. There could have been all kinds of alien races that have been trying to contact us for years, and then we couldn't hear them because of all the noise. The far side of the moon doesn't have that issue. Okay, the far side of the moon never faces towards the Earth, and so that part of the moon basically can have be radio interference free, which is great. Okay, one other thing is hard to see. To transport materials from the moon upwards, to lower the cost of space transportation, we have used traditional rockets for a long time. It's time to think outside the box as far as rockets, electromagnetic mass drivers, for example, for things like lunar materials, could significantly lower the cost of transporting them. And I'm talking about, 1,000 times less than a rocket. By the way, launching from the moon, because of its lower gravity and no atmosphere, is 10 times cheaper than launching from the Earth to go into Earth orbit. Picture. So you'll have these great bases and colonies. And by the way, this is a tourist attraction. That's the Apollo 11 site, so you can prove to your kids the astronauts did land there. And I hope that when Google Space or Google Moon lands or whatever on the moon, that we make sure that they don't traipse around the Apollo 11 site specifically, because I think that should almost be hallowed ground if we can make that an international park. Next. Lunar fuel. The sun has been depositing particles as it shoots out its streams of energy constantly on the moon for centuries and centuries. But on the moon, there isn't much in the way of anything. There's no wind, there's no rain, so most of the materials just basically pile upon pile upon pile from the lunar debris, so from the solar debris coming out. So basically, we believe that there's a lot of helium-3 which exists in the surface of the regolith on the moon, and that you can take advantage of that, hopefully, in the future when we develop things like fusion reactors. And it could be a cottage industry just getting helium-3. Next. And so we'll have these wonderful facilities on the moon, I'm hoping. Next. And we'll have lunar ice mines. By the way, there's going to be choice places on the moon. Now, while countries cannot physically, according to international law, I can't go plant the flag on the moon and say, the moon belongs to the United States of America. No. But companies can stake out areas on the moon and physically claim it. I would imagine it would be similar to miners' rights. And we need that because we need the invisible hand of economics, as much as we hate to think of it, drives almost everything that we do. And if, for example, I can stake out a spot. Hey, could you go back to the moon for a second there, Dale? Okay, if we can stake out spots which are very valuable. For example, any crater that doesn't get sunlight on the moon, which has had, for example, comets which have been crashing into it for centuries, and it has ice in there, and there's no way, there hasn't been sunlight in that crater for a long time. Man, this is a gold mine on the moon because you have ice. Ice mines are going to be incredibly valuable, and whichever organizations claim those, and I believe they will claim them, are basically going to be rich. You know, when the miners went out initially, the miner 49ers came here to California, the people that got rich weren't really the miners. They were the railroads, the people that carried the people out there. They were the ship firms. They were the merchants that sold stuff. They were the manufacturers. The miners initially got people excited, but once the excitement falls down, the basic infrastructure is where the money lies. And so you guys are part of that infrastructure, and I think it'll be helpful. The next thing is asteroids. Asteroids, of course, there's a minimal gravitational pull, so you don't have a problem as far as a gravity well. As a matter of fact, it's hard to physically stay on the asteroid. You're going to have if you push away, like jump up in the air, chances are you have escaped the gravitational pull of the asteroid. So you've got to be very careful of how you would move on an asteroid. But recently, the Department of Defense did a study of economically recoverable, high-value materials here on the Earth, and we're running out. We're running out big time. And most of those materials happen to be that exist today are in China. So we don't want to have to be necessarily dependent upon China, So or go to war with China. I think it would be a lot better to look elsewhere. We have lots, and each of these asteroids is just chock full of various things we can use on our planet. So we can move these asteroids. People have talked about using space tugs. We can physically attach a magnetic linear accelerator to them. A wide variety of ways of physically moving them. Slowly, make sure that we do not get into the Earth gravity well. That's the bad thing. But if we can get, for example, if we can get into one of the Lagrange points, point of equal gravity with the Earth-Moon, it would be awesome. You could do massive mining, and especially if you get an iron-nickel asteroid, you can make, of course, steel as well as you have those other minerals. Next. So we're going to start mining asteroids. Next. Keep going. We're going to figure out how to use tethers to work with the asteroids and actually be able to have gravitational fields which are similar to the Earth in space, physically using asteroids tethered together. Next. And we're going to hollow out these asteroids and use them for living quarters. Next. Keep going. And we keep building and building, and eventually we have, keep going, entire space cities. Next. Next. Which orbit the Earth, and one of the problems we might have is you may end up with, there's a whole new science called astrosociology. You may end up with entire different versions of the human race. So for example, if you have children that were born and raised in a zero-G environment, the Earth would be absolutely torture for them. These people may totally move away from wanting to ever go to a a world with a gravitational pull. So you'll probably have sections on these colonies which you have similar to Earth, maybe 1/10 or maybe 1/2 Earth gravity, so that you can avoid some of those issues. But maybe that's a good thing. Maybe having different types of sociological entities of, okay, you're going to have people that are going to be on Mars for their whole lives, but they had 1/2 Earth gravity. People that live on the moon their whole lives with 1/6 Earth. Maybe as we move out, you're going to have different versions of humanity. And that probably is a good thing. Next. Imagine these huge cities that we can build. And, you know, the difference between science fact and science fiction is time and money. Okay? This cell phone, back in the 1960s, was science fiction. You know, James T. Kirk dug out his communicator and called up Scotty. Well, you know what? This exists today. Now, I wish the aerospace industry was moving as fast as the electronics industry. But, you know, in all honesty, if the business community could see a massive amount of profit to do something like this, it would galvanize our whole industry, and we'd do things like this. Next. By the way, am I on a schedule here? Because I don't want it to take too much time.
No, we're good. Have probably about 20.
Okay.
About 25 minutes, maybe?
All right, that's fine.
25
so,
minutes.
one of the key things which we're facing here on our planet is a shortage of renewable, affordable energy. Okay, there's only so much petrochemicals which we can get out. Wind energy, okay, when it's not windy, isn't doing any good. And by the way, those windmills, if they're by the coastline, which gets lots of wind, they're causing our air defense system massive problems because it's raising the radar floor so that enemies could fly, anyone from a terrorist to a smuggler can easily fly over the coastal areas that have those type of windmills because it's interfering with radar. So it's not a good thing in those areas. So if you're going to do those windmills, put them in one, okay? Don't put them on the coast. But space solar power, I believe, is going to be the answer. We're currently looking at some first steps where basically you can just reflect the energy down to the Earth to the existing solar farms, and so you have energy 24 hours a day at the solar farms. So right now they're only good, during the daytime. Phase 2 would be to then do an energy conversion in space, and then convert it to a laser beam. And the advantage there is you can have a much smaller area that you can put this energy to. For example, the military in forward bases, or for JPL, if you're looking at interplanetary powering for something, or on the moon, instead of having to carry a nuclear reactor like you're going to have, like RTG on the Mars Science Laboratory, the Curiosity, you could have beamed energy come down and keep your system charged up using the beamed energy without having to have a large amount of space. And then lastly, for space solar power, microwaves. It's the most costly thing because we're talking about things which are hundreds of kilometers in diameter when you get to that size, and it costs. And where do you get all that stuff? Well, from the moon. Once we develop an infrastructure to manufacture, and from the asteroids. It's a lot cheaper to do that than to haul it, a brute force from the Earth. And I'm hoping that we can convince industry, because we're talking about, for the energy industry, hundreds of trillions of dollars of profit. From the sun will go out, so it's not an inexhaustible source of fuel, but probably for the next 2 billion years or so, it should be operational. So that's a lot better than sucking out the water. The oil from our plant, which will be gone in the next 200 years. And by the way, if you have enough energy, you can desalinize water. Water is a big shortage we're having too. If you have enough energy, you can desalinize seawater, and you can use that to have all the drinking water you need. And you can also electrolyze that